Hey guys, we're going to be solving system of equations by substitution. So we've got two examples. Example A, you see this here. Now in the past we've been able to graph these, but today we're not. But real quick, if we were, we would put that in slope-intercept form, this is already in slope-intercept form. And if you remember, slope-intercept form is y equals mx plus b. It's in that format. This is not. In order for this to be in that format, you'd have to take the 2x and put it on the other side. And so the only way to get rid of it over here is subtract 2x, but if I subtract 2x here, I gotta subtract 2x here. That cancels out, it moves to this side, and it becomes y equals, in this situation, it'd be y equals negative 2x plus 5. And then you can graph it, find the y-intercept, and all that. But we're not doing that. We're gonna do it by substitution. So the first step in doing this is we got to solve. So step one, we have to solve an equation for one variable. So we're going to solve an equation for one variable. And it can be any variable you want. You only got two of them. So x or y. Now, we're not going to actually get a number for the variable, but we're going to get an algebraic expression. Now, we already have one. Y equals x minus 4. So we already know what y equals to. It doesn't give us a numerical answer, but this is an algebraic expression, so we can use that. So we already got it. So y equals x minus 4. Okay? That's all you need. So we got it. That's pretty easy. Step two. Step two is we're supposed to substitute the expression. So substitute the expression which is what that is. That's an algebraic expression for the y. I should probably put that in parentheses. For the y in the other equation. Key word there, other equation, and solve. In this case, we're going to be solving for x. Okay, so let me highlight that. Other, not the same one. This was one of our equations, right? The whole thing's the equation. This is the other equation, so we're using that one. So we're going to take 2x plus y equals 5. And instead of using the y, we're going to know that y equals x minus 4. That's the expression, what y equals to. So we're going to take that and plug it in here. Okay, so let me see if I can do that with a different color here so that makes maybe a little bit more sense. So if y equals that expression, we're going to take that and plug it in, substitute it in for that. Okay? So now it's going to be 2x plus x minus 4. So 2x plus x minus 4 equals 5. So hopefully you can see that the difference in color there might be a little bit difficult, but that says that's x minus 4 in green. And that's kind of hard to see. This camera's not really doing a good job of showing the difference in color here. But anyways, let's go ahead and solve for x. So let's add like terms. So the only thing we can add or combine here is 2x plus x. That's 3x minus 4 equals 5. And then this is just a two-step equation. We add 4 to both sides. We get 3x equals 9. Divide both sides by 3. X equals 3. So now we have x equals 3. Step 3, I'm going to put step 3 right here. Step 3, basically all we got to do is plug it back in. So we're going to plug in, or substitute the value of x in the expression, the previous expression, to solve for y. Okay, and that's what we're looking for. We're looking for y, all right? We're looking for y. So that's the previous expression. So y equals x minus 4. Again, we didn't know what it was. All we had was the algebraic expression. But the answer, the technical answer, is, well, let's see what it is. We plug that in here. Y equals 3 minus 4, and we get y equals negative 1. So our answer, the solution for this, is going to be 3, negative 1. And that's going to be our solution. And so the question is, how do we check this? So on graph paper, again, we talked about graphing this earlier, but I didn't want to give it away quite yet. But basically, when you graph this, you're going to look at the two equations. You already got this in slope-intercept form, but if I put this in slope-intercept form, this will become y equals, I'm going to subtract 2x from this side, subtract 2x from that side, so I can get rid of it over here. So it's going to be negative 2x plus 5. This is y equals x minus 4, in this case 1. 1 over 1, 2 over 1. So we start with our y-intercept. Our y-intercept is negative 4. So let's see, 1, 2, 3, 4. Go up 1 over 1. So that one's going to go right here. So our line's going to be something like that. Something not really perfect here since I don't have a grid to go with. So that'd be x. So y equals x minus 4. Sorry, I didn't show that to you earlier. So our y-intercept is negative 4. Go up 1 over 1. That's the slope. For this one here, our starting point is positive 5. So we start up here. 1, 2, 3, 4, 5. Sorry, it's a little off. Again, I don't have my grid paper here. But basically, we're going to go down 2 over 1. So 1, 2 over 1. And then that's going to connect. Basically, if I can, well, that's pretty bad. It's not perfect, but hopefully you get what I'm doing here. Y equals negative 2x plus 5. And so they should cross each other somewhere. And again, it's not perfect, but you get what I'm getting at here. So it's 3, negative 1. That's where they cross each other. That is the solution. That's where it is. Okay? So that's example 1. I'll show example 2 here in a second.